Lesson 4.7, Statistical Significance. Our objectives for this lesson are to be able to find and interpret the margin of error and confidence interval for a study, and to be able to determine whether a result is statistically significant. Let's start by defining what we mean by statistically significant. A set of measurements or observations in a statistical study is said to be statistically significant if it is unlikely to have occurred by chance. So, for example, if I flip a coin 100 times and I get 54 heads and 46 tails, we're not going to say that that's evidence that the coin is unfair, that it favors heads over tails. We're going to say instead that that's just a coincidence. It was just chance that we got a few more heads than tails. It's not really surprising. But if we were to flip a coin 100 times and get, say, 65 heads and 35 tails, now we start thinking maybe this isn't just a coincidence. Maybe this is evidence that the coin is unfair, that it favors heads over tails. So what we're going to try to do in this lesson is figure out where exactly we cross that line from, well, this just occurred by chance, to, okay, now this seems to be evidence that something is happening here, that the patterns that we observed in our study are statistically significant. Next, margin of error. For a single sample of size n drawn from a large population, the margin of error for 95% confidence is approximately equal to 1 over the square root of n, where n is the size of our sample. So, for example, if we want to know what all the voters think about, say, a certain ballot initiative, we are going to conduct a survey of a few hundred voters, and we're going to use that sample, the results from that sample, to infer what the entire population thinks. And even though we're going to choose our sample carefully, and we're going to make sure that it's as representative as possible of the entire population, we're still not going to be exact. There's going to be some error based on the fact that we're only asking a small portion of the population. And so the margin of error is trying to say exactly how much wiggle room we're going to need with this sample statistic that we come up with. And that's going to be based on the size of our sample. And then from that margin of error, we're going to find the confidence interval. So the confidence interval is an estimated range of values which is likely to include the actual population parameter. So remember, we've come up with a sample statistic, which is the result of our survey, but now the population parameter is what the actual, if we were able to ask every single person in the population what our actual result would be. And we're saying that we're 95% confident that this range of values includes that actual population parameter. And we're going to find that confidence interval by adding and subtracting the margin of error from our sample statistic. Our first example tells us that a 2017 Gallup poll of 1,035 adults found that 37% of those surveyed believe that the United Nations is doing a good job solving global problems. And we're asked to find the margin of error and the 95% confidence interval. So our sample size is 1,035 adults. And so we're going to use that to find the margin of error. The margin of error is equal to, or approximately equal to, 1 over the square root of n, where n is the sample size. So in this case, that's 1 over the square root of 1,035. And if we plug in the square root of 1,035 into our calculator, we get that that's about 32. And so 1 over 32 is going to be approximately equal to 0.03 or 3%. So our margin of error for this study is 3%. That means that our confidence interval is going to be between 34% and 40%. And we found that by taking that 3% margin of error and subtracting that from our sample statistic and adding it to our sample statistic. So 37% minus 3% is 34%. 37% plus 3% is 40%. So we're 95% confident that the actual population parameter, the actual number, percentage of people who believe the United Nations is doing a good job solving global problems is between 34% and 40%. Our second example tells us that in November 2020, pharmaceutical companies announced the results of a study on a newly developed vaccine for COVID-19. In the study, which involved over 43,000 participants, 8 people in the vaccinated group developed COVID-19, compared to 86 in the placebo group. We're told that calculations show that the probability of this difference between the groups occurring by chance is less than 1 in 100,000. And we're asked, is this result significant at the 0.05 level? Is it significant at the 0.01 level? And would it be reasonable to conclude that the vaccine works? So what we mean by significant at the 0.05 level is we mean that there's less than a 5% chance that the results that we observed, there's less than a 5% probability that the results that we observed happened by chance, by coincidence. And here we can clearly see that this is less than a 5% probability. 1 in 100,000 as a decimal is 0.00001. And that's clearly less than 0.05. In fact, it's clearly less than 0.01. Significance at the 0.01 level means that there's less than a 1% chance that the results that we observed occurred randomly. And so, yes, this is going to be significant at the 0.05 level and at the 0.01 level. And would it be reasonable to conclude from this that the vaccine works? Yes. By showing that the probability that this occurred by chance is so low, we've shown that this result is significant. That is, that significantly fewer people who received the vaccine developed COVID-19 than those who didn't receive the vaccine. And that's what we were looking for. It shows that the vaccine is doing its job, that it is in preventing people from developing COVID-19.